Hi guys, since I will not be at school for the rest of the week, I decided to try to record a video over the area of triangles to help you out. I know you've spent the first part of the week really talking about area of rectangles and hopefully area of parallelograms, so all of that knowledge will help you when we're working with area of triangles. When I do return to work, I will make sure to go back through all of this with you in deeper context. So I'm going to do the best I can on this video and post it to Google Classroom so you can review it if you need to after class. So I'm going to go ahead and use a Pear Deck just on Cami to the best of my ability on my computer, talking about area of triangles. And what we're going to do is we're going to use what we know about the area of rectangles and parallelograms to discover the area of triangles. So when I scroll down to this slide here, you guys will notice that in the bottom, there is a typical square right here. I'm going to do the best I can with my mouse to try to highlight this. And a square is a type of rectangle. It's just that all sides are equal in length. So when you find the area of a square or a rectangle, we would look at what we now call base and height. This will make a little more sense today. This has a 3-unit base and a 3-unit height. So for area, we would obviously do, I'll go ahead and make this a little bit bigger. Area equals 3 times 3, and area would equal 9 square units. Okay, so area would be 9 square units, and you can see the 9 square units within the square. Well, what they do up here, which I would do if I were in class with you, is if I were to take a pair of scissors and literally slice the shape, which, bear with me here, we go, right from corner to corner, and completely remove this part. As with the square, so I'm going to go over here and I'm going to write area again. We would have started with 9 square units, but I cut half of it off. So mathematically, that would be the same thing as dividing by 2. So if we take 9 and we divide it by 2, the area of the triangle would be half, or let's see, 4.5 square units. So the point of this slide is to just illustrate that any triangle that you ever dealing with area, you are always going to basically find the area of what would be a rectangle and cut it in half. And hopefully this will make more sense when I show you some more examples. So this is the formula. I'm not as concerned about you memorizing the formula as I am about you just understanding why we do what we do. So just to highlight for understanding, when you're finding the area of a rectangle or parallelogram, which you guys have been working on for the past few days, you just take the base or the length, what you guys used to call the length, and you multiply it by the height, and you get your area. Well, we're still doing that with the area of a triangle, but all triangles are half of rectangles or half of parallelograms. So you still have that base times height, but we are either going to divide it by 2 or multiply by 1/2 in order to take half of the area. So another thing that's really important to understand, and I'm hoping that when you worked with parallelograms, you talked about this, but there is a reason that we have a base and a height. So a base and a height, they have to have, and I will go ahead and write this down, the base and height need to be perpendicular to each other. And what perpendicular means is they have to create a right angle. So the nice things about rectangles, and I'll go ahead and draw one on here, is that rectangles always include right angles. You've never really had to consider that before because when you've always found area of rectangles and squares in 5th grade or 4th grade, the right angles were just part of the shape. Well, when you start getting into parallelograms, which I don't really think I can draw on here, but that's when you start getting into more of those slanted looking rectangles, I guess. So I can try to draw one here. Looks a little bit like this. Doing the best I can, but And in this case, you don't really have a base and a height relationship, so you would have to create a height line. So with a parallelogram, it would look something like this. A height line could go here, a height line could go here, a height line could go here, just as long as it would be what we call perpendicular to the base or have a right angle. Well, the same thing is true with triangles. So in this case, I'll go ahead and use the colors I've indicated here. I'm going to highlight the base in yellow. So with this right triangle, this would have to be the base, the 15 feet, and the 8 feet, let me find pink for that, would have to be my height line because those are the two dimensions that create the right angle. This 17 feet here is obviously part of the triangle, but there is no right angle relationship between the two sides. So you have to pick the base and height that form the right angle. So over here on this other triangle, your base would be 11.4 centimeters, and your height would have to be the 17.7 centimeters. And this is due to the fact that they create the right angle. So that's going to be very important moving forward with finding area of triangles. I'm also going to use this slide to show you that both of these triangles, any triangle really, originates from a rectangle. So if I were to go ahead and draw a line from here to here and here to here, you can see I've created a rectangle. And then same over here. If I draw a line here to here and here to here, I have also created a rectangle. So the idea is that you're still doing the 15 times 8. This would also be 8 over here. This would be 8 right here. I'm sorry, 15. So you would be doing 15 times 8, but since it is a triangle, you cut it in half. Over here, we would have done 11.4 times 17.7, and then you would cut it in half. So on this next slide, I'm going to go ahead and talk a little bit more about different types of triangles. So here we have a right triangle again, and that's because it includes a right angle. So it's a little easier to see your base and your height. So here's your base, and here is your height. And if I were to create a rectangle out of this, I would just connect all the vertices, and you'd have a rectangle, right? And in order to find the area of the triangle, we would remove that. Now over here, this is called an acute triangle because all the angles inside of the triangle are less than 90 degrees. So we don't automatically have a height line there. So we would have to create a height line. And so I'm going to go ahead and do that for you. So if you go from what we call the apex, which is the very top point there of the triangle, and we go all the way down to the bottom, I have now created a right angle within the triangle. So you can see it right here. And what's cool about this is I don't necessarily have to draw it from the apex. Now that I have, you can see that I could have drawn it from this vertex up, or I could have drawn it from this vertex up. And all three of those green lines are exactly the same length because they are all height lines of the triangle. So I'm going to go back to my highlighting for a second here and show you that your base would be here along the bottom, and our height line could either be from this vertice up, from this apex down, same length as over here, or from this vertice up. And I would still use that base times height and then cut it in half. And hopefully you're starting to recognize that there is a triangle, or I'm sorry, a rectangle starting to form here if I were to connect all of these. So that triangle is half of this rectangle, meaning when we find the area after we do the base times height, we cut it in half and we'd have our area. So this just kind of goes over what I discussed, that no matter what type of triangle you have, you can always find the area by basically doing base times height and dividing by 2 or multiplying by half. The height or the altitude, the apex, which is the top part of the triangle, can be found by drawing a line segment from the vertex to the opposite side. So in other words, When I go to the very top of the triangle and I draw a line down, that can be considered my height line. We can also see it from this vertex up and this one as well. So just for one last demonstration with height, I want to make sure that we fully understand that, because if you're looking at this triangle here, this very first one, we would not be able to just take the sides that we have and find the area. We would need to have a height line. So with the first triangle, my height line can go from the apex down. That is always an option. That also can show you that it can go from this vertex up or from this vertex up. They are all exactly the same length. Now this middle triangle is a right triangle. So we have that nice right angle built in, which would basically force this orange line to be your base and this orange line to be your height. This is an obtuse triangle because it has an obtuse angle in there, but again, no right angle is obvious. Now with obtuse triangles, it's a little trickier because if you go to the very tip top point, which is your apex, you do still draw a line from the top down, but it is going to go outside the rectangle or triangle, and that is okay. Because notice you could also draw that height line from the bottom up. You could also draw it from this vertex up. And hopefully you're kind of seeing how when you draw these height lines, they're sort of making it look like a rectangle could be formed, because again, just to reinforce this idea that any triangle is always half of a rectangle. So we really want to keep that in mind when we're finding area of triangles. Okay, so I'm going to do a couple of examples. You can do these with me if you want, or you can just watch, but I just want to make sure that we have the concept down. So this very top triangle here, it is a right triangle, so that's good news. That means that I have a height line right here, and I have a base. So when I am finding the area of this triangle, I am going to do 16.8 times 12.6. Now that would give me the area of the rectangle if it existed. So I'm going to go ahead and draw that back in for a second. Okay, because if I did 16.8 times 12.6, I would have everything on the inside in there filled in. So I'm going to go ahead on my calculator, type that information in. I am okay with you guys using calculators on this. Okay, and I get all right, we would get 211 and 68 hundredths centimeters, but that would be if we had the rectangle. We don't. We have a triangle. So I need to remove this half. So mathematically, the way that I do that is I'm going to take that amount and I am going to divide it by 2. So divide it by 2, and my final area would be 105 and 84 hundredths centimeters squared. Now, this triangle over on the right, this is an obtuse triangle, meaning it has an obtuse angle more than 90 degrees. So you will notice they did for me, which was nice. You still have a base of 12. This dotted line isn't part of the triangle, so you would not count that as part of the base. But because it's an obtuse triangle, it does force the height line to be outside of the shape, and that is okay. Even if we drew the height line over here, or if we drew the height line here, they're all going to be the same length. They're all going to go from the apex down to the base. But you just want to make sure that the base is 12 and not anything longer, because 12 is the only part of that shape that we want to work perpendicular with the height line. So I'm going to go through the same process again. Area would equal, thinking of it as a rectangle first, 12 times 21. Because if I did 12 times 21, that would be as if I had a full rectangle. So again, if you need a calculator, you type in 12 times 21 and you get 252. Now 252 would be our area if we had a rectangle, but we don't. We have half of that, so we have to divide it by 2. So we take that answer, divide it by 2, and our final area is 126 feet squared. Now, the final triangle in the middle down here, this one is an acute triangle. That just means that all of the angles inside the triangle are less than 90 degrees. We'll go into more detail of that when I return. But we want to look for that base and height. So the height line should stand out because of this right angle that they gave us. So that means this right here is the base of the triangle. It's the only length that is perpendicular or has a right angle with the height line. And again, that height line could be drawn here, and it could be drawn here. So for my final area, I would say area is equal to, now I would have to take the 20 and the 8, add them together because that's my full base length, multiply it by 15 inches because 15 inches is my height line. The 25 inches and the 17 inches are part of the triangle, but they are not the height line. So 28 times 15 is 420. Now 420 would be the area if this was a full rectangle, but we have to cut it in half. So we're going to take the 420 divided by 2, and your final area equals 210 inches squared. So hopefully that is a decent intro into how to find area of a triangle. It is truly the same process over and over again of understanding that these are just half of a rectangle, no matter how you slice them. When I return, we'll do a Desmos activity that kind of explores that a little bit deeper, so you understand how that works with the different types of triangles. But for now, I just wanted to make sure with this lesson that you really have the conceptual understanding that you're just going to take what you know about rectangles, find the area, and then you cut it in half to find the area of a triangle.